Period 3 class, talking about chapter 17. All right. We're going to be doing quiz A right now, so make sure you flip in your packet to quiz A. We have a problem that says the American Red Cross says that about 11% of the U.S. population has type B blood. A blood drive is being held at your school. All right, let's think. Could this be a Bernoulli trial? Let's check our three things. Who's got one? Oh my gosh, there are people here. Two possible. What are they, Catherine? What's a success? Type B is success, and the other one is not type B. So we're going to clump all the other ones into a failure. Excellent. That's one thing. What's the next thing? What's our rate of success? 11%. Our constant P is 11%. All right, very good. What's the third thing? Independence. Okay, let's think about this. All right, somebody walks in, right, to donate their blood. They donate. The next person walks in. Are those independent events?
Yes.
Could you think of a way that they're not?
Maybe like there's a group of people who actually never mind.
What? If they're related. Nice, Victor. Well done. So we're gonna hope that these people are not related. All right. So Bernoulli, check. We're good there. The next question: how many blood donors should the American Red Cross expect to collect from until it gets a donor with type B blood? We are doing what, Leslie? You said it. We're waiting. This is waiting. So, Maria, I think I heard you say it. This is geometric. All right, so really the key word I was thinking there was until was telling me waiting. Then I have another key word. That is important, but no. Do you know what the other? What is it, Diana? Expect what up? So that means I'm finding what? Expected values, correct. Nice. So just take a sneak peek back to your notes if you don't know the formula for the expected value in the geometric model. It is 1 over P. All right. Our probability of success is 0.11. So take out your nifty calculator and let's figure it out.
9.09.
Excellent. Are we saying that the 9th donor is going to be our first donor with type B blood? No, but I'd probably be surprised if it was the first one, or if it was the 40th one, right? That would be surprising. We'll talk more about that at the end. Okay? Questions on 1. Let's do 2. What is the probability that the 10th blood donor is the first donor with type B blood? What are we doing here? Is this a number of successes out of a certain number of trials, or are we waiting until get our first success? We're waiting. We're still waiting. I know it's weird, but we're waiting. We're waiting until when?
Till the 10th.
The 10th one is our first success. All right, so if we're waiting to get our success, this is going to be geometric again. All right? No, I want to do a little different because I need to use the probabilities without being in a denominator. All right. So think about this, Victor, right? The first person comes in. Okay. Gosh, I wish I had my screen on. They could see me walking. They donate blood. Was it type B?
Probably no.
Well, according to this scenario, no. All right. The second person? No. Third person? No. You see where I'm going with this? 4th, 5th, 6th, 7th. The first one is the 10th. So how many not type B do we have? 9. So what I'm going to do is let's write down Q, right? Q is 1 minus 0.11. What's 1 minus 0.11? 89, right? So I have 0.89 to what power?
10.
Not the 10th, because 10th one, Thomas, is my type B. So I'm going to do one less than that and go to the 9th, because I have 9 people in a row that are not type B. So then, Thomas, on the 10th one, I've got my type B. All right? I'm not sure if that was what your brain was thinking, Victor, but that's what I want to see.
That's still technically geometric.
This is geometric, yes.
Okay. I thought it was expected.
You're good, not expected. We're looking for probability now. Yeah, so our answer won't be in donors. It'll be a percentage. All right, so now I don't use the function in the calculator. I just go to the calculator and type this in. All right, so take 30 seconds, type it in. Let's see what you get. Didn't work? I'll just do it right there. Take a different one. Okay, just do it right there. Take it. I'll reset it. Get it to work. I heard Leslie something? No? Just kidding.
0.039.
0.039. Confirm? Leslie, same thing? Yes? I'm going to pause here. Everyone okay with geometric so far? Okay. All right, number 3. What is the probability that exactly 2 of the first 20 donors have type B blood? Are we waiting now to get our first success? No, we're not waiting anymore. We're saying an exact number of successes out of a number of trials. Guys, we are now using binomial. All right, so we're trying to find exactly 2 out of 20. And I want you to leave space. All right, so you see how I wrote my work here?
Yes.
Leave a little space after this equal sign. All right, so I'm going to write down my failure rate, which is 0.89. How many people, and donating blood is never a failure, but how many people are not type B in this scenario? 18 Thomas is right? We want 2 out of 20 to be type B. So 18. Right? And then Thomas, how many are type B? 2. So right now that looks just like what? The one we did just before, which is geometric. But we just said not geometric. Here's why. All right? If we think of this scenario, the first 18 people, not type B. But the last 2 were type B. But is that what I have to happen here? No. Could it be the first 2 people are type B? Yeah. Could it be the first and the last? Could it be the 4th and the 8th? So what we're seeing here is that we have lots of different combinations for 2 out of 20. So enter the choose function. Oh my gosh, I'm so excited. All right, so we're going to do n choose k, which is 20 trials, and we're choosing how many to be a success? 2. All right, and this is a formula that you're never going to use, right? Because we're going to use the calculator, but I like to do it. It's fun. So we have n factorial, so 20 factorial, over 2 factorial times n minus k factorial. Now, Jonathan, he knew what a factorial was. Very good. All right, 20 factorial, all right, is 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. That's 20 factorial. Nope, not times 0. So I'm going to write 20 times 19 times 18 times 17. I gotcha. You thought I was going to do it. All right. Let's write down 2 factorial. What's 2 factorial? 2. I'd like you to put times 1. I know 2 times 1 is 2, but I want you to put it so you know. All right. Times. What's 20 minus 2? 18. So 18 factorial is 18 times 17 times 16. And what I'm hoping you see is that if you look at the top and the bottom, I know I didn't write all the numbers, and there's a reason, because 18 times 17 times 16 times 15 all the way down is on the top and on the bottom. So they're going to cross out. So really, all I care about here is 20 times 19 divided by 2. So what is 20 times 19 divided by 2? It is 190. So how many different ways can we have 2 successes out of 20 trials? 190 ways. So I need to put, remember that space you left? Hopefully you left it. I'm going to put in front here 190. Go ahead and take a moment. Type that into your calculator. And hopefully now you just saw the difference between the geometric and the binomial models. Yes, Thomas.
Are you going to show us how to do this in calculus?
Absolutely, because I would never do that by hand. But man, it was fun, wasn't it?
So fun.
Thank you. Do you want one? Here. No, you're just giving up. It's not even halfway. We're just done.
Yeah.
I got 0.28. What's the number after the 8? 2. What's the number after that 2? Okay, so 0.282. You okay, Rick? Confirm? So we're good with that? All right, so put your pen or pencil down once you have that and pick up your calculator. I'll turn mine on. All right, mine's on. Here we go. Ready? So we're going to go to, all right, we're going to go to second VARs, okay, which is distributions. All right, so right here where it says VARs, the blue one is distributions. I want that. So second VARs. Okay, bless you. Scroll down. Keep scrolling until you see A and B. Do you see A and B?
Yes.
A and B both say binom, which stands for binomial. Now there's two versions. There's PDF and there's CDF. All right? Here's how you know which one to use. This problem said exactly 2 out of 20, correct? Exactly 2 out of 20. So when it's exactly a number, you're going to use PDF, right? Exactly a number, PDF. So click for this one. We're going to click letter A. PDF. Trials, 20. Probability of success, 0.11. Exactly how many successes? 2. Hit paste. Oh, sad. And there's 0.282. It was, right? And if you really want to, come see me for office hours. I can show you how to do factorials in this as well. So if you want. Yes, student. There's weird things? Oh, yeah? Well, you clicked Poisson PDF. Yeah, you did. Come here.
That's Victor, by the way.
Right there. Right there.
Yeah.
It's the same.
Okay, let's get out of it.
It changes it to.
Okay, all right, okay. I believe you. I just got the magic touch, Victor. That's all it is. Questions on number 3? Questions on number 3? Let's go number 4. All right. What is the probability that at least 2 of the first 10 blood donors are going to have type B blood? What are you guys thinking? Are we waiting to get our first success? Or are we getting a number of successes out of a number of trials? It's the second one. It's binomial still. Now, how this is going to be more challenging is it says at least. So what would work for at least 2 out of 10? Wait for it. What would work for 2 out of 10? At least 2 out of 10. 2 out of 10?
3 out of 10.
3 out of 10, 4 out of 10. See where I'm going? So which ones wouldn't work?
11 out of 10. Wait,
No. Well, it's too many. 1
0.
or 0. So just like we did this in chapter 15, when you saw the words at least, I'm going to find the complement and then take that away from 1. Okay? So what I'm going to do is find the complement, which you guys just told me is x equals 1 and x equals 0. So 1 success out of 10 or 0 out of 10. And we can do this by hand, but the calculator can actually give us this probability. All right, remember that CDF one? CDF stands for cumulative density function. So it's going to, whatever number you put in, let's say I put in 6 out of 10, it's going to find 0 out of 10, 1 out of 10, 2 out of 10, 3 out of 10, 4 out of 10, 5 out of 10, 6 out of 10, and add them together. Sick. All right? We don't want 6 though, right? All right? What am I going to type in? So, okay, Australia, your brain is right. If I was doing 6 out of 10, at least 6 out of 10, I'd plug in 5. So in this case, I'm going to plug in 1. So if I plug in 1 there, it's not just going to tell me 1 out of 10. It's going to go to the one below it, which is 0 out of 10. So it'll take both of those and add them together. Okay? So let's go to the calculator. Back to second. Mars. This time we're doing letter, I think it's B for CDF. Letter B is CDF. Poisson. Okay. The trials are 10 trials, I believe. The constant probability of success is 0.11. And again, this is the mistake that students will make. Australia's brain already got it, but a lot of students will plug in 2 here for the X value. But if you do 2, then that's including 0, 1, and 2. Do we want to include 2 right now? No. We just want to do 0 and 1, not at least 2 out of 10. So just do, always take 1 less. All right, so in this case, 1. Again, this is not my answer, right? This is the probability that we get 0 out of 10 successes or 1 out of 10 successes. So let's put that down, 0.697. All right, but again, this is the complement. So don't forget to do 1 minus 0.697. Let me show some work here. This is at least, so greater than or equal to 2. All right, go to the calculator, do 1 minus that. And you get 0.303. So your hope is that on the AP exam in May, that this question is a multiple choice question. All right, because then you just use the calculator, be done. Most of them are. Questions on 4? All right. And again, come see me if you have any issues. We can go over all the button pushing. I know it can be challenging to remember all the different buttons, right? Second Vars. Okay. Number 5. Number 5. It says, the blood drive has a total of 150 donors. Nice. Assuming this is a typical number of donors for our school blood drive, what would be the mean and the standard deviation for the number of donors who have type B blood? So we're going to be using the binomial model again. Now I'm going to be using the 2 formulas here. For mean, it's N times P. And for sigma, which is the standard deviation, is the square root of N times P times Q. All right, so here's the mean. We have 150 donors. What is our probability that they're donating type B blood? It's our same P we've been using. What's the P we've been using? 11%, right? All right. So what's 150 times 0.11? It is 16.5 donors. Again, I know it can be weird to say that. We can't have half of a person, right? But it's okay when we're talking about a statistic, right? Which that's what this is. Let's find sigma. The square root of N times P times Q.
And then 3.832.
3.832. Anyone confirm, Jonathan's 3.832? Got one here. Raul's got it. I'm going to round it, Jonathan, to 3.8 just because I ended up having for my decimal for the mean was just in the tenths. But Jonathan, if you wrote 3.832, that's fine. Okay. Everybody okay with that? Just using some formulas? Again, am I saying I'm going to get exactly 16 donors that donate type B blood? No. Right? But I'm expecting it to be around there. All right, let's go a step further. Number 6. We're surprised by our low number of type B blood donors at the blood drive. So I don't know what it is yet, but it's not 16 and a half, something less than that, okay? And the American Red Cross is thinking, you know what? Your number is so low at your school, maybe your area doesn't have the same rates that we expected. Maybe the rate of 11% is actually too high and should be lower, okay? How many type B blood donors would we have to see in our blood drive of 150 to convince us that 11% needs to be lowered? All right, and this is asking you to go from the binomial model, which we've been working with for the last few questions, and move to the normal model. Okay, what do we have to check to make it okay to do that? It was a condition that we mentioned. Success and failure condition. Awesome. So I'm going to do a quick check over here of the success failure condition. All right, all that is N times P and N times Q. We already did one of these, right? We did N times P. What is 150 times 0.11? 16 and a half. Let's also do 150 times 0.89. This is going to be my failures. And you can do that, or you can just take the 16 and a half and subtract it from 150, right? We only have 2 options here. Either they're type B or they're not. And you get 133.5. Excellent. Here's how you decide if it's okay to move from the binomial model to the normal model. Look at those 2 numbers. Are those 2 numbers 10 or higher? Yes. Right? 16 and a half is getting closer, but still above 10. All right, so if they're both 10 or higher, you're good to go. You can use the normal model. We are now allowed to use the normal model because of that check. All right, so now I'm going to use the normal model. All right, which means I'm going to draw my curve. Hopefully you guys remember that. What's going to go right down the middle? 16.5 is right, Victor. The mean. All right. How many standard deviations do I care above and below that mean? 3. Nice. Gosh. Isn't it all coming back to you? All right. Just wait till 2 weeks. Less than 2 weeks. Oh, my gosh. Only 11 days. Nope. 12 days for you guys. All right. So 16 and a half. I'm going to move up and down 3 standard deviations. And I'm using this 3.8 from the previous problem. So 16.5 plus 3.8, part of my math, is that 20.3, I think. And then is it 24.1? And then is it 27.9? Anyone check me?
Yes.
Yes? Confirm, Thomas?
Yes.
You're just saying yes. But
Yes.
okay, let's subtract. This one's a little tougher. Is it 12? Is it 7? Yeah. Okay. Oh no. 8. Is it 9? Yeah. And then 5.1. Once you get here, go ahead and put your pen or pencil down. Okay. Let me try to bring us back to what the question is asking. Okay. We are surprised because what happened in our school blood donation? There were not that many type Bs, okay? So that means I'm going to be looking at numbers below what I expected. I expected 16 and a half. So let's look to the left. Where would you need to fall to the left of this that would make you think it was unusual? You can think back to what we did in chapter 6. So you can totally do that. The AP exam is okay with you looking just past 2 standard deviations. I have always, since I was in high school, I've always gone to 3. All right? So if I see 5 donors that donated type B blood or less, so 4, 3, 2, 1, or none, then I'm thinking, you know what? I think that 11% should be, we should change it. We should make it lower for our area. Okay? So that's what I'm going to write. If I see 5 or fewer type B blood donors, I would think the 11% is too high. Thomas, if you wrote fewer than 9, that's fine. 9 or fewer is also fine. Maybe not 9, probably 8 or fewer, because 9 technically is still within, but around there. Okay? Now, I know the question didn't say this, but what if they had said that our estimate is actually too low? We got to think the opposite. So we actually are seeing whoa, we're seeing a lot of people that are donating type B. So for me, if I think that our estimate actually needs to be raised because it's not high enough, I'm thinking we need to see 28 people or more donating type B blood. All right, that's how I've always just gone with unusualness in terms of the normal model. So 3 standard deviations is my cutoff above and below. Any questions on 6, on any of it, on all of chapter 17? Great job, guys.